Howdy, my name is Luke Hibner, and today I will be giving the project proposal for the final project for control systems. The project that I chose was an automatic pet watering system. Upon completion of this video, the YouTube video link will be posted below per the assignment requirements. The project description is seen here as a pictorial aid in a conceptual block diagram with the components listed on the left. As one can see, starting from left to right in the conceptual block diagram, there is a 12-volt power supply connected to the H-bridge module. This H-bridge module will use the 5-volt output to power the Arduino and the water sensor, and we'll use the 12-volt output to power the flow jet pump. The flow jet pump will be connected between the control water reservoir, as seen in the pictorial aid, and an external water reservoir, which is used for surplus water. The water sensor will tell the controller, the Arduino microcontroller, how far up the tank the water is. If a disturbance is inserted into the system wherein the water level starts to drop below the target level, it can be seen that the microcontroller will read this signal in and then send out a PWM signal to the H-bridge, which will then send that PWM signal to the flow jet pump. Flow jet pump will pump more water into the apparatus until the water level is at a significantly high enough level to reach the target. And in this case, the water will then shut off from the flow jet. In this case, a full PID control will be able to be implemented, and the water sensor will act as the sensor, the pump and the reservoir will act as the plant, the microcontroller will act as the controller, and the rest will act as the system. The flowchart can be seen below, where the target is the tank being filled all the way. That way your pet has ample water. This signal from the controller will go to the tank and pump apparatus. Once a disturbance is inserted into the system by the experimenter removing water from the reservoir, this will result in a pump PWM signal. This pump PWM signal will tell the pump to exude control and raise water volume in the reservoir. Once the water level sensor is continuing to read throughout the breadth of this experiment, once the water level is at a sufficiently high enough level to where the target minus the water level sensor reading is equal to a good enough steady state value for control to have been implemented, then the project will cease until another disturbance is inserted. The timeline is seen below in another pictorial aid. The project proposal will be completed by October 21st, and after that, detailed design of the software, construction of the hardware, and simulation will occur. After that, prototyping, testing, and debugging of the system will ensue. Finally, in production and closing, the demo will be prepped, the prototype will be scaled up, and the presentation will be ready to demo along with the prototype. Given that I am doing this project by myself, there is no need for a distribution of work slide, because I will be garnering every facet of this experiment. There are the works cited, and thank you for your time.